Good morning and good afternoon for some of you. My name is Jennifer Joyce, and I am the Regional Vice President for Sales for the Western Territory here at Condusiv Technologies. And today we're going to be talking with you about how you can achieve 2x faster SQL experience guaranteed. Now, just a couple of housekeeping things here real quick. This webinar is really broken out into two parts. The first part is what we would consider maybe the thought leadership portion of the webinar, and we're just going to dig in under the hood a bit into the technology stack to explain what are some of the I/O inefficiencies that are occurring. What are some of those I/O degradation issues that are taking place in the environment, especially if you're running SQL Server, particularly if that's on a virtualized workload in your environment, and kind of what's happening under the hood that's stealing some underlying IOPS and throughput and performance that could be causing the underlying storage subsystem to be working much harder than it should be, and ultimately why you may not be getting as much performance as you think you should on those SQL workloads. So we're going to cover that portion. Then we're going to jump into some inherent I/O penalties, what's really occurring. We're going to bring to light a couple of items and give an overview real quick, no more than 10-minute overview of what our software actually does. And just a kind of a precursor here, V-locity is a set and forget software utility. It just runs in the background on Windows servers. It is tackling those I/O inefficiencies that we're talking about solving so that we can guarantee that 2x faster performance. Now, obviously, one of the biggest compelling events about this and finding a software solution to solve this software problem is that you can get way more performance out of the SQL servers and the hardware that you already have without having to continually forklifts upgrade and add more shelves and add more, add more hardware and throwing more hardware at the problem, because that can really add up and get very expensive over time. So we are a unique solution that can really solve this problem, again, with a 100% software approach. Take a new angle and look at this. And at the end of the webinar, we will be giving a complimentary NFR that is more than a $500 MSRP value to you. And, we do that because we believe in the product so much. Ultimately, the proof is in the pudding. And I also want to introduce my cohort, my partner in crime, who's on the line with me, Howard Butler. Howard is the Senior Director of Systems Engineering. And for any of you car fans out there, if you are ever on a one-on-one call with Howard, chat him up on the cars, because not only does he specialize in accelerating performance on computers, he is also a race car instructor. And he takes that both of those things pretty seriously. So Howard, just wanted to introduce you there real quick.
All right. Well, thanks very much, Jennifer. Always glad to join you here. And by the way, don't let her title fool you guys. Even though she's a Regional VP of Sales, she's also quite technical, as you're going to find out as we go along. But one of the things I did want to mention, Jennifer, before we forget, is that we do want to make this session rather interactive. So there is a Q&A box off to the right-hand side of the webinar screen here. And so as we go through discussing the various different underlying inefficiencies in Windows and how we go about solving that, if you guys do have questions, please feel free to write them up, toss them over there in that Q&A box, and then we'll either get to them during the course of the discussion or so forth, or at the very end, we'll take time for a Q&A type of answer session. So, Jennifer, back over to you.
Great. Thanks, Howard. And yeah, and when you type into the Q&A box, please try to hit the Q&A box rather than the chat box, because in the Q&A box everyone can see those questions. And we will keep this, we'll move through the content pretty quickly. We like to keep it interactive. At the bottom of the hour, we'll go into that Q&A session. But if you have to drop off at the bottom of the hour, just one other housekeeping item, because I may not announce it then, we are recording the session and you will receive a recorded copy. So if you do have a hard stop and you have to bounce out, go for it. You're going to get your free copy of the software. If you can't stay the whole session, don't worry. You will also get the full call recording at that time as well. So let's hop right in here and let's kind of get down to work. Now, some of you joining today may not have heard of Condusiv Technologies. And you may be wondering, gosh, why this team even think they have the credibility and the thought leadership to be even speaking on the subject that we're talking about today? Now, I personally, when I show up at a presentation or get an overview like this, I want to know who I'm talking to, but I don't need it, belabored. So I'm not going to spend a whole lot of time on those, just real high level so you know who you're talking to. We are a 35-year-old software company. So I think if you translate that into software years, that's a long time. We are the 12th oldest software company in the world. And we originally started out as a company called Diskkeeper. Now, some of you may have heard of that company and the Diskkeeper brand. In fact, a large number of you have probably even used that software in the past to defragment hard disk drives. But about 5 years ago, maybe 6 years ago now, the company brought out some really revolutionary intellectual property to the marketplace that had absolutely nothing to do with fragmentation. It was all about how we could reduce the noisy I/O, all that unnecessary I/O, as it turns out, and especially on any given SQL systems, we found that there's between 30 to 40% of the I/O traffic that's just pure noise. It's just stealing IOPS. It's stealing throughput. And in fact, those customers of ours who have a couple gigs of extra memory on server side can really take advantage of that software. And, we're going to be offloading 50% or more of the I/O from storage and getting that faster gain. Now, for that work, Gartner named us Cool Vendor of the Year. When we launched this into the marketplace, there's just no one to compare us to. They could not fit us into a quadrant. So that's the acknowledgement that they wanted to give us. And we've had that product, V-locity, in the marketplace for over 6 years now, and it's had very, very nice market growth. It's now used by over 2,500 mid-market to large enterprise customers, and there are various iterations and pieces of the technology as well, OEM'd by kind of the Samsungs and the SanDisks and Western Digitals of the world as well. So if you haven't heard of us, clearly you've heard of them. We've private labeled a lot of stuff through those organizations as well. And Howard, one of the other things on here that actually is not on the slide here that I wanted to ask you to speak to real quickly. I know you were really closely involved with this initiative a couple of months ago where Microsoft actually named us as the first ever software vendor certified on their SQL I/O reliability program. And that was a pretty big deal.
You're right, Jennifer, and I can kind of consider this a pretty elite level type of certification. Microsoft does have specific criteria to make sure that other applications, kind of like ourselves, are fully compatible with their software and their platforms. In this case, we're talking about SQL Server. And as you said, we're the only software vendor in this group. But I think we're in pretty good company with the people like EMC, Dell, HP, and others. And, besides all the testing, we also had to go through a very exhaustive Q&A session with a panelist of SQL experts to kind of get past this level of certification. So I kind of consider this a pretty significant accomplishment, Jennifer.
Yeah, it really is. And considering that we're the only software publisher that's ever gotten this, usually it's just reserved for hardware publishers, it's a pretty big deal. And thanks for that background, Howard. One of the things that we like to do is we like to kind of keep our finger on the pulse of what's happening in the environment. So what we did was kind of part of the thought leadership portion of this is we do an annual survey to find out what's happening. And we're probably on our 4th or 5th year of doing this survey now. But we want to know, what is this I/O degradation issue that steals performance and what are people experiencing from it? So earlier in the year, we did this survey, again, our annual survey, and we believe it's the largest independent survey done on I/O performance. We get every year at least 1,000 IT professionals respond. And it's interesting because one of the things that we ask about are, which applications are the hardest for you guys to support? And are you getting actual degradation to the point where you're getting user complaints? And on the last survey, we had a 28% response rate say, yes, we are having issues and performance so bad on SQL that we are getting complaints. And, the prior year it was 27%, and we've kind of been hanging in that a fourth of all respondents or a little more than that are having this issue. So if you're on this webinar, it's probably because the SQL performance is hitting you in some way. You're probably in one of those 1 in 4 organizations that are having this issue. And we really kind of wanted to find out as well in that survey, we asked this question: of all your IO-intensive applications that you support, which one is the most challenging, that you're struggling with the most? And you can see from the word cloud, the frequency makes the larger font. We're dealing with databases, and SQL is front and center in this. It really is a sweet spot. Now, you may have already picked up on the fact that we install within Windows, and we can optimize performance on any application in Windows. It just so happens that SQL is that big kind of gorilla in the room of performance degradation that people want to address, and we do a very, very good job of it. So we want to go ahead and talk just a little bit about the environment here. Let me just jump onto this next slide because I think we've had enough of a setup. What we want to do is look at, before we go into the degradation piece and what we're talking about there, we want to look at what does an optimal IO profile look like. What should the IO profile look like when you're getting that peak performance? Now, as you can see here on the screen, this is obviously a very rudimentary extraction of your IO profile, but I think the takeaway is pretty obvious and immediate. What you can see here is a nice, large, clean, contiguous read and write pattern. And you can see that you're getting a healthy payload of I/O with every I/O operation. You can notice how nice and sequential the nature of the traffic looks. And this is really what we want, an optimal environment to get that peak performance from the underlying storage, whether that's flash, hybrid, whatever you might have under there. And the moment that you take a server and you separate it. So let's say that you go from a physical to a virtual space and you virtualized it. Now you've added some layers of complexity, and you've also added more complexity to the data path. So it starts getting a little bit tough. And what happens is really more like this. We're going to take a look at now what the ideal state is to what's probably happening in the environment today. Now, another immediate takeaway here, suddenly you've got this environment where the I/O characteristics, and this is what's happening today, they're much smaller, they're more fractured, and they're more random than they need to be. This is what I like to refer to as a death by 1,000 cuts scenario. And this is where your underlying architecture is churning away the process workloads, but ultimately it is having to work much harder than it really needs to. This is akin to pouring molasses all over your flash storage. And, you're penalizing the storage performance. Now, we kind of like to call this the perfect trifecta for bad storage performance. You've got small, fractured, and random I/O characteristics in there. And I'm going to make two points here real quick. One of them is the disk used to be the weak link, right? Now, we've got a lot of performance coming into the SAN space. We've got all flash. We've got environments that have 100,000 plus IOPS. In fact, Howard and I just got done doing a deployment in an environment that has 600,000 IOPS and an all flash pure SAN storage, and they were still having performance issues. How can that be? So the disk is super, super fast these days, right? But what you're dealing with now is you go upstream and the operating system, the OS is now the weak link. It cannot dish out the data as fast as your hardware can handle it. You are losing 30 to 40% of your throughput because the latency is no longer in the hardware, it's upstream in the software logical layer, and that's why you need a software solution to come in and handle it. And the other thing I'm going to make a side comment on here real quick too is, what about those 100,000 IOPS? What about the 600,000 IOPS this one customer came in with? Let's talk about that real quick. We're not talking about the vertical space that you have to use all of that capacity. We're talking about the 1% or 10% of the IOPS capacity that you are using. That can be used 30 to 40% more efficiently. So I'm not looking at how high we can burst. I'm looking at, hey, of the 8,000 IOPS you're using right now, can we get rid of half of that? And by the way, can we change that from being that small, fractured, random I/O profile for the 8,000 IOPS you are using and turn that into half the IOPS and have them be large and sequential, which if you do those benchmark tests on storage, you know that sequential I/O is much easier to process than random I/O. So just a little side note there of kind of laying down what the problem is and why hardware alone isn't enough to solve it. Now, I'm going to talk real briefly here before I turn this back over to Howard for a couple of his comments on the two things that we're looking at on this slide. The first thing we're looking at in this slide that I want to focus on is on the bottom section here, and that's the I/O blender effect. Now, the I/O blender effect is very, very likely you have heard that term before, and that's because we helped Gartner coin that term a little more than 5 years ago, especially when virtualization was really picking up steam and a lot of people were going, you know, hey, we're 50, we're 60, we're 70% virtualized. The I/O blender effect is what happens the moment that you virtualize more than one server, you put more than one server on a host, right? Now, the moment you do that, there is no fix for what happens next. As great as virtualization has been for server efficiency, one of the biggest downsides is that it adds complexity to the data path. And what happens is that the host hypervisor now mixes and randomizes otherwise sequential I/O streams and now delivers to storage that randomized pattern. And the moment you add that third VM and the fourth VM, guess what? It's just compounding and amplifying the effects of randomization even further. Now here's the thing, is that most organizations don't see the full performance penalty that comes with virtualization and all that added complexity. They don't really they're not aware of it having crept up on them because most organizations virtualized slowly over time, and now they're fully virtual. Some of our biggest and best customers, though, one in particular I can think of, went from 0 to hero on their virtualization. They went 100% physical to virtual overnight by flipping the switch on a huge data center build out. And Howard, this is a really good example, and you were involved in this one. This was Christus Health. They are one of the top 10 largest healthcare providers in the United States. They are located in Texas, and they virtualized one particular environment that had 2,000 servers in the data center overnight. And Howard, would you share your insights with us on that one?
Yeah, thanks, Jennifer. With Christus, they did their testing like any good shop would do. They did their testing on individual systems, and like many, they expected that when they went physical to virtual, that they get the same kind of performance that they had tested out. But when they virtualized all those systems, unfortunately, they didn't get that kind of performance. What they saw was a huge performance degradation. And during their analysis, kind of what they found is that it wasn't CPU related, it wasn't memory, but what it really wound up being was that it was I/O bottlenecks, Jennifer. And that's what kind of caused their issue. Now, their first reaction was, gee, I guess we're going to have to upgrade all of our storage, and we're going to go to an all-flash array in their environment to solve that type of issue. But before they did that, they got a hold of our software. I think they attended one of our in-person type of presentations that we were doing. They got a copy of our software. They installed it in their environment, and sure enough, we were able to make those bottlenecks go away or dissipate significantly. So, Jennifer, rather than them spending, I believe it was something close to $2 million for that hardware upgrade for their storage to an all-flash array, we were able to save them from doing that. So that way they could use those funds for other type of practical purposes.
That's just fantastic. And one thing, just a housekeeping item here real quick before we can carry on. I just want to mention we do have a lonely Q&A box here. Normally by now we usually have about 5 or 6 questions in there. So if you have a question you're thinking, please drop it in. We will start taking those kind of interactively throughout the conversation. I see one now coming in. A skeptic has arrived, and I really appreciate the challenge. So keep dropping all of these questions in, and we will have a really good Q&A session here coming up. So I want to continue here, though, and just mention that, with Christus Health, their results were so powerful that they published a case study with us. That's up on our website. They are now deployed across the entire enterprise, over 2,500 VMs. Check out the case study along with, another 20-plus case studies that we have. Now, as difficult as the I/O blender effect is that we've been talking about, there is an even worse penalty that's happening a little bit more up the stack, okay? And so what we're dealing with here is the I/O inefficiency that's coming directly from the Windows operating system itself. Now, this is where we really start getting into some differentiation here. Now, if you've just joined, or maybe if you joined earlier, you may have heard some allusion to this in the past with our Disk Keeper legacy, but we're the ones who can actually explain this because we have the only proprietary software that solves this. And in fact, the Windows operating system just doesn't play well in general, but we all know that. But especially in a virtualized context, it really, really starts to struggle when it's delivering this data, when it's extracted from the physical layer like that. So some of the severe inefficiencies in the handoff of data between the Windows OS and the underlying storage, there are no APIs that can connect the two other than using rudimentary framework that Windows has always used by addressing logical disks to write the data. And Howard, this creates a real serious problem because the Windows operating system, for any given file that would be written, let's say with 1 or 2 or 3 IOs, minimal number of IO operations, Windows ultimately takes any of those files and breaks it down into much smaller IO than it actually needs to be. And ultimately, what happens is you end up with a situation where you're processing way more IOs for a single file than really should be written with just 1 IO. So Howard, maybe you could just shed a little bit more light on this for what's actually happening here and why Windows is so inefficient in the handoff of data.
Well, the Windows file system takes a one-size-fits-all type of approach, Jennifer. So when a file gets created or is extended and modified, the Windows file system really doesn't know how big that file is going to grow to. So what it will do is that on the logical side, dealing with how NTFS sees this storage volume in the free space, it's going to look for the next available free space allocation. And if the file extension that your application is trying to write is bigger than that segment of free space, Windows will write what it can, tie off, and then allocate the next available segment of free space. And each one of these operations continues down the line until the entire file extension has been ascertained. Each one of those is a separate individual I/O request that has to be sent from the guest VM to the hypervisor, to the host, from the host out perhaps across the network over to the storage device, and then only then is your storage device actually processing that request. So what we wind up with is a whole bunch of these small, random, fractured type of I/O requests rather than a nice pattern of large sequential operations. And that's how we go about trying to solve this type of issue. But as you can see, you're not getting all the performance you could when you're doing those small random IOs from the system itself. And if you ever look at benchmarks from a storage perspective, they'll generally give you two numbers, Jennifer. They'll give you measurements on random IOs as well as sequential IOs. And you can always notice that those nice sequential IOs outperform the random ones. So if we can help enforce to the Windows file system to do these really nice large sequential requests, you're definitely going to get better performance out of your storage.
No, that's great, Howard. And I'm just going to take one of the questions real quick from the inbox, and thank you guys for starting to put your questions in. Please keep putting more in. If you're thinking the question, probably someone else's as well. There's one question, and we will address everything in here. One question that just popped out was, does it still help servers with Flash? And there's a really good example of this. There's a case study that we just recently published with the University of Illinois. Their hardest hitting databases were their applications where they were actually running some on Oracle databases and some on SQL. And they were already running those databases on the latest Dell servers. They had already installed Dell Compellent all-flash arrays in their environment, supporting those heaviest workloads that they had, and everything was running fine on day one, but over time, within a year, that performance had degraded to the point where they thought they were going to have to add more flash on to get more IOPS to meet their SLAs to their customers, their internal users. But before they did that, they came across our software in researching for solutions, and since our evaluation is free, they figured they had nothing to lose. They threw it on there, and sure enough, they doubled the performance on top of all flash arrays. So yes, it's very, very relevant. They kind of were jaw dropped on that because you think flash, I think that the industry and the marketing that we've all received about flash is so fast it solves everything. And quite frankly, you're on this webinar for a reason. It probably hasn't. And yes, this really does help. And a lot of that is because of where we sit. We sit at the top of the stack. We sit right inside the operating system of the Windows OS, and we fix this. And we're going to talk about how we fix this and why that works. So let's move on to the next slide here. And this gets right into what we do. Now, I mentioned that both Howard and I would give you just a quick overview of what our software does, and then we can talk to you about the handoff of the free NFR, the free copy of the software that you're going to be getting. It downloads and installs seamlessly, literally in just a couple of minutes. It's set and forget. You can just come back 7 days later and take a look at the UI and see what's happening with it. And we have, first of all, the first thing I want to talk about is our patented write optimization engine, and second we'll be talking about our patented read optimization engine. So, first let's go into looking at what we're talking about on the write optimization. What are we doing there? Now, we already talked about how Windows has this issue where it's only looking for the next available allocation at the logical disk layer, whether this well, I'm not sure we talked about that yet, but Windows does that. Windows will look for the next available allocation at the logical disk layer, whether it's the right size or not. Now, we're going to give Windows some credit, as I mentioned on the University of Illinois case study, is that on a freshly formatted NTFS volume, we're probably going to get ideal I/O performance on day one, but it's going to start degrading pretty quickly, and we're going to move away from that nice sequential traffic pattern into that small, chopped up, tiny pattern. And as time goes on, files are written and erased, rewritten and extended, and that's where this issue really begins to creep in, and that's where the degradation really starts to show up. Now, Howard, if you're trying to write a 64K file and the next available space is only 4K, it's my understanding that Windows will actually use that 4K and fill it, and then they'll split the rest of the data, find the next available allocation, fill it, split, fill it, and they'll keep doing that until the whole file is fully written, Howard. And we have a patented technology that can actually solve that problem and deliver each write with the ideal optimal density for the I/O. So, Howard, would you just expound upon this a little bit more, what kind of intelligence we're adding here to help the Windows operating system go from kind of what we see at that first level where we have all this excessive I/O being sent down just to fewer, larger, contiguous I/O being sent down?
You're right, Jennifer. And as I said before, the file system doesn't know how big that file creation or extension is going to be. So as you said, Windows is just looking for the next available allocation, next available segment of free space. Well, we're doing something quite simple. In the background, we're able to monitor the behavior of the system, and we're saying, hey, if this file type or this application is creating a particular file, then when we see that file being created or extended, we know from our previous historical or behavioral analytics of your system running, your applications and so forth, being able to know how big that file ultimately is going to be. So we can feed that intelligence back to Windows, back to the NTFS file system. So the file system now is aware that this file that's being created or extended or modified is going to be roughly this particular size. So it's not going to waste its time trying to allocate from these little tiny slivers of free space. It knows exactly and can jump to what's the next largest segment of free space that best can contain the data that this file is going to grow to. So we avoid creating all these tiny, random, fractured, or split IOs. And we wind up getting these very nice, large sequential writes. So now, it's very simple that we're just providing that intelligence to the file system so it can do a better job. But I kind of like to use this analogy. If you wanted to carry a gallon of water from one place to the other, you have your choice. You could do that in 100 small individual little Dixie cups, and just go back and forth and back and forth and back and forth, and eventually you would have moved a gallon of water from one side of the room to the other, let's say. But don't you think it would be much more efficient if you just had a single gallon jug and you could just take all of that water and move it at once from one side of the room to the other? That's what we're really doing with the file system. We're helping it to enforce those nice sequential writes. That's going to be more efficient. And by reducing the number of writes, subsequently there's less conflicting I/O that your storage system has to process. And we all know that the winner of the race is going to be the application that does the same amount of work in the fewest number of I/O requests.
That's great, Howard. Thank you for covering that for us. And kind of what I'm taking as the net takeaway here is that this intelligence helps the Windows OS find the best allocation at the logical layers, since the next availability is rarely, if ever, the right size. Now, Howard, as powerful as that engine is, and as much as that engine alone helps customers, it's not the only thing that we're doing. There is a second engine, and this is a read optimization engine. And this engine is very, very, very different from the first one. This is actually a DRAM read caching engine. And we're establishing a tier 0 cache strategy in your environment by simply leveraging the idle available DRAM sitting there on any given VM or physical server. And we're just utilizing, borrowing, I would say, a portion of that memory that's sitting there otherwise wasted, and we're using that to serve up hot reads. Now, the real genius in this engine is it is completely automatic. You do not have to carve out or allocate any memory for cache, and the software is aware moment by moment of how much memory is unused at any given moment. And it's only using that unused section to serve hot reads. So that way you will never have an issue of resource contention. You're never going to have to worry about memory starvation because the intelligence of this engine is completely dynamic. Now, obviously, if you're really heavily constrained, you need the memory, it's called for something else, we back off, we give that resource back, and it's hands off for us. Now, I know there's got to be some more questions about our technologies of our IntelliWrite and IntelliMemory. We're going to be going into the Q&A very shortly, so if you've got the questions, now's the time to start dropping those in there. But a lot of times, the second thing I want to cover about the IntelliMemory is a lot of times when someone starts hearing about caching, they think this is going to be really capacity intensive and you're going to need a lot of memory to be effective. Not so. We found that if customers can maintain just an average of 4 gigs of free memory on a system, which most systems already have that and more anyway, we can often serve up to 30 to 50% of the read traffic and offload that from going down to storage. So it's not always just about being capacity intensive. Our behavioral analytic engine is so powerful that we can just leverage that small sliver of DRAM and get that that offload happening directly from memory. And keep in mind that reading from memory is going to be 15 times faster on average than reading from an SSD. So just a little bit goes a long way here. And Howard, is there anything that you'd like to add on to that before we jump into the last 2 slides and go into Q&A?
Well, there are 2 things that make us very unique with our IntelliMemory caching. And that's one of the reasons why 9 of the top 10 PC manufacturers have OEM'd our technology and bundled it onto their platforms. But of course, you haven't heard of us because they license it under their name and so forth. But the 2 things that you indicate is dynamic memory usage. And that means that we're only going to use memory that's free, idle, unused. It's not being called upon by Windows. Applications aren't latching onto it. It's just sitting there. It's a free resource that we can borrow and utilize for our cache. Now, if there's a demand for memory, then we're going to purge or give that memory back up, give it back to Windows, so there's never going to be any type of memory contention. And then on the second part, as you might know, our intelligence is what we put in to determine what to put or keep into the cache for the best benefit. A lot of caching technologies try to use something like, oh, hey, this data was read in, let's go ahead and populate the cache just because you read it once, let's say, and then kind of crossing your fingers and hope that you're going to read it again. Well, we're not doing anything like that. truly we're actually monitoring the behavior of the system in the background, and we're tracking and seeing what data blocks are you truly accessing repetitively over and over again. And that's what's going to get placed into our cache, the most frequently accessed data blocks for reads. And if we do cache it, you'll get the best performance gains because that's where some of the data is likely to be offloaded away from having to go to storage. Imagine if we could, simply satisfy those IOs directly from memory. Memory-to-memory data transfers are, measured in microseconds, millionths of a second, where even going to flash and SSD is still measured in milliseconds, thousandths of a second. So we're significantly faster in satisfying read IO requests directly from our cache. And in doing so, it alleviates a lot of that extra IO traffic from having to go to storage. So as you can see, kind of the big performance gain is that, that it can provide is that offloading that IO traffic will increase the bandwidth at the network storage level. And I think that's a very important takeaway, Jennifer.
Thanks, Howard. And just again, housekeeping, anyone who has to drop, I know we're at the bottom of the hour, we're running a little bit long today. Go ahead, we will send you a recording, but if you can hang out with us, we're going to be hopping into this Q&A here in just a second. So really kind of to start wrapping up the last couple of slides here, we have a lot of use cases. We have 20-something case studies on our website. Head over there and check some of those out if you want. I'm just going to highlight one or two of these here real quick. A real good example is ASL Marketing. They had a huge batch import job that they would do. It had millions of records, and it would take 27 hours to complete. Now, I was lucky enough to personally be involved with this deployment. They did not have it in budget to rip and replace their hybrid storage with all flash, so they tried out our software, and we cut that 27 hours down to 12 hours. Even I was impressed with that one. So 15-hour reduction, and they left that hardware in the floor. They did not have to do their upgrades. Another example on here, Stockport College, their servers were crashing on enrollment day due to IO demand. It was taking an average of 15 minutes to process one student record. And again, another situation where they just didn't have the budget to rip and replace. They threw us in, made a couple of tweaks, and we got that down to 5 minutes. And again, got them into meeting their SLAs and not crashing. And then they did what a lot of people do is they liked it so much on that server that they looked at other use cases. They had a long-running payroll batch job. They ended up putting us on their Crystal reports, and we brought a lot of other stuff down for them too. We had one report that went, and this one also was stunning, from an hour to 10 minutes. Mileage varies. That's a spectacular result. We don't get that every time, but when it happens, it's real nice. So, the next one, I'm not going to spend much time here, just more benefits that we've had a lot of people tell us. Alvernia University jumps out. They had a learning management system that was actually slow enough that it was going down when students were taking tests. And we threw the software out there, no hardware upgrades, and it stopped crashing, and their testing platform was working again. So let's just take a real quick look at what the UI looks like. What you're going to see here is that we have very good reporting, clear reporting on how much IO we're reducing. Of that, how much is reads. Of that, how much is writes. Typically, we see about a 30% reduction in writes and about a 50% reduction in reads. So that's our mileage on average. We're also going to show you how much storage IO time you've saved. And then we're going to get a little bit deeper into the UI once you actually have the software in your hands. There's a bunch more screens and more reporting that will show you the caching metrics and things like that. Now, I see one of the questions in our Q&A box is about how do you measure and how do we side check with a third-party independent verification tool. So I'll touch on that in just a second. But before I do, let me wrap up the last slide here. What you want to do for best practices when you get your free copy of the software, what you're going to want to do is drop the software in there, but you're also going to want to make sure, since we're focused on SQL, as you know, SQL will gobble up all of the memory if you don't have a memory cap left in place. And a lot of people follow Microsoft best practices. They already have a cap in place. They may be left 2 gigs for the OS or something like that. In this particular case, since this is probably one of your heaviest workloads that you have the most attention on, we're going to ask you to cap at least 8 gigs free on the OS side for us to start tapping into for caching. preferably if it's a really big server, give us at least 16. Now, again, this is not a recommendation for every server in your environment. Most servers already have plenty, 2 to 4 gigs free, we're good to go. But on this, 1 to 2% of the servers in your environment that are your heaviest hitters, your biggest I/O, let's dedicate a little bit of extra resource to those systems and give us, I'm going to ask for 16 gigs on those servers if you can give it to me. If you can't, give me 8. If you can't, give me 6. And that's going to give us the best showing. And put those memory caps in place, before you install Velocity, or even after, it's fine. And then we'll do a monitor the dashboard where you can actually hop on a call with myself, Howard, or your respective sales or technical resource here at our company, and we'll give you a quick walkthrough and review of what that looks like for you. Now, there's one last thing I'm going to cover, and this is kind of another best practice, and this is how many servers should you try Velocity on? I have a 3-level approach. The first level that I like to call is just your first level 1 is just hit the SQL server. Just go for that server. A huge number of people come into us because their SQL servers are timing out and getting deadlocks, right? That's a big use case, and we get that to go away, but I have seen where we need to go to level 2 to make that happen. Level 2 is one of 2 things. One is let's hit every single VM. Remember that I/O blender effect we talked about where the I/O from all the neighboring VMs can be impacting the workload you really care about? Well, that's a very real thing. And I've seen the level 2 deployments work very well where you hit all of the VMs on that host. But in the case of SQL, you may have other servers that are touching that data. You've got other servers that are pulling or contributing data to that SQL server. You may want to seriously consider dropping Velocity on all of those servers. So you may have a three-tier architecture, and you've got the app server and the SQL database, and you've got maybe a web server. Consider seriously dropping Velocity on all 3 of those servers in that kind of a scenario. That's where we see a lot of the issues clean up, because even though the other smaller servers aren't pushing a ton I/O, they are touching the I/O, and they are adding latency that makes a difference on those timeouts. We've seen it over and over and over. The level 3 deployment is put it on everything. Just drop it on 100% of your VMs. In fact, we're doing 3 of those proof of concepts right now with customers. We've got an environment with 90 VMs. We've got another one with 18 VMs and another one with 32 VMs. And they're literally putting, after doing their Q&A test dev environment, they're literally putting Velocity on every single VM in their whole environment through our free trial. You can actually really drive this car at its full speed on the racetrack before you buy it. And so we do offer that 30-day evaluation. And there's 2 tools that I'm going to throw out there real quick, and you guys can start dropping this into the Q&A box if you want this. The first tool, which is not in the slide deck, is called the Condusiv I/O Assessment Tool. This is a free tool that we offer that, and now talking about third-party metrics, that taps into perfmon metrics already on the server. So we don't have to install anything. We're just using remote WMI calls to collect existing perfmon data from your target servers. We'll pull all that perfmon data out, put it into a readable UI, and we can hop on a call and see if your servers are even good candidates for our software in the first place before you invest a lot of time. If you want that tool, you can drop IOAT into the chat box or into the Q&A box. Just drop in IOAT. You may want to type in the word both, though, because with both, what you would get is also the Velocity Management Console. So with the Velocity Management Console, it would come as a trialware. From that, you can deploy Velocity to as many VMs or physical servers as you would like. So type in what you want. Just type in IOAT or VMC or both. And we will make sure after the webinar that you get those extras be above and beyond just the NFR that we're going to deliver to you. So we're going to hop into that Q&A now. And I appreciate, we have Howard, almost everybody has stuck with us. We're running a little bit long here today, but we have nearly everybody still on the call with us. So let's hop into the Q&A that I know people are waiting for. So the first question, I'm sorry, I can't see the name on it, maybe RE or the initials. It says, I'm skeptical of a tool that measures its own success, but the values don't match when measuring the same key indicators from other tools. Specifically, which key indicators should be measured to benchmark and prove the improvement after install. Now, I'm going to jump in with one quick answer on this, just as something that I'm going to say, and then I'm going to turn it over to Howard to give you some of those. Here's the tools we recommend, but I'm going to give you a kind of an example that shifts the paradigm. Howard and I were on a call with someone who wanted to measure I/O latency. They wanted to specifically measure I/O latency, and they were expecting it to get shorter. Well, if you think about it, we're making I/O bigger sometimes. So you may have 4K I/O versus 16K I/O. And if you measure a larger I/O, it takes longer. So if you're only looking at one metric of one I/O and its latency, you actually may go, hey, this software slowed everything down. But what you're missing is the fact that there's 30 to 40% less I/O. And instead of it being small and split in random I/O, you now have large sequential I/O. And again, there's 30 to 40 to 50% less of it. So your overall throughput has now changed, and you're going 30 to 40% throughput difference on the data. The other thing you want to look at is what's the workload. Is the workload you're testing exactly the same? Did you do 50 gigs of work here and 50 gigs of work here, and were the same files, the same traffic? So there's a lot of variables that we look at when we go into this, and there are a lot of third-party tools that we can recommend to you to side check. Howard, let me come over to you real quick with a couple of the tools that I know that we use a lot.
Well, you know, I'm going to kind of re-echo one of the things that you just stated, and that is benchmarking tools in general rarely, if ever, produce I/O traffic or workload conditions similar or equal to what you do in production. Benchmarking tools generally just beat the system to death, doing all kinds of activity, but not anything close to what you do in real life. So the real place to evaluate or benchmark our solutions is in your production environment. Give me your worst system. Show me which applications you're having trouble or struggling with. Okay, and we'll use those responses for those applications and so forth as the true real acid test in your production environment. But I realize that that may be a bit of a stretch, considering you haven't done business with us and you want to take a more cautious approach. If you do need to benchmark it in a controlled environment, then let's make sure that we're simulating a workload that's reasonably close to what you're doing, and that is a variety of different kinds of IOs, different sizes, different relationship between reads and writes, okay, different percentages of sequential versus random IOs. And one of the tools that kind of comes to mind that I've worked with and seen great success with is from Intel. The old iometer, or depending on what part of the world you live in, some call it iometer. But with iometer, we can create a workload that does a lot of these different type of IOs, okay? And we can measure a period of time with the velocity features turned off. That's going to be your baseline, okay? And then we can turn the velocity features on and now capture kind of that before and after. And what I expect to see is that you'll get greater throughput. More work can be done with the velocity features turned on, then and you'll get faster response time than you would with velocity turned off. So that's kind of my take on benchmarking and using third-party tools to evaluate.
No, that's great, Howard. And if someone does go into their production environment, they can also just see a difference by, hey, did it run faster? Did your deadlocks stop? And we can also use perf line counters if we need to there. So there's a lot of ways to side check the veracity of our software, and we'll be happy to walk through that with anybody on our testing. We have a lot of confidence in our software, and that's why we give a free copy away. We really want you to try it because we know you're going to love it. The next question is this problem specific for SQL Server set up on VM only or applicable to physical servers too? And Howard, do you want me to just answer that one real quick?
Yeah, go ahead and take that one.
Okay, so I'll take the easy ones, Howard. So, so on this one, yes, we are good for physical or virtual. One of the things I'm going to comment here is that Windows is Windows is Windows. And it doesn't matter the context that Windows is in. And you could even put a third part onto this question, what about the cloud? Because a lot of people are starting to migrate some of their bigger workloads up to the cloud. As long as you have control of that OS and that image, yes. So remember that the cloud is just somebody else's server. So whether it's a physical server, a virtual server, or someone else's server, this is very, very relevant because we install right inside the Windows operating system. It is a 100% software solution. It doesn't need to be tethered to anything, so we're not using memory pools at the host level or flash hardware cards at the host level that you might have to tether to or anything like that. You can still vMotion or live migration in your environment, and because we're contained inside the VM, we just travel with that VM and continue providing that optimization. We've already answered, does it help with servers with Flash? Absolutely. Chris asks, just so I understand, this solution is only applicable to virtual machines. I think that's a duplicate of Ganesh's question, and no, it is not. It is physical virtual cloud as long as it is Windows. In fact, this even applies to VDI, and VDI is a huge use case. In fact, Howard, we should probably add a VDI slide to this deck because I keep forgetting to mention it. We have a ton of people using us on VDI environments where you've got very, very high VM density, and you can have a potential of a lot of I/O churn. How are you measuring the performance before after? We have touched on that. We have various tools we can use in addition to looking. The best place to go is into production. What is the problem you are trying to solve? And let's solve it through deployment and actually showing you and getting hands-on with the software. Okay, next question. Zach, Howard, I haven't read the question yet, but let me throw you in on this one. It says, in regards to your guys' I/O blocking versus fragmenting, how does this process not further fragment or more quickly fragment, especially in regards to these, quote, smaller frags of memory that fit virtually none of the writes that consistently get written? So, Howard, I see the answer here. Let me flip this one over to you.
All right, sounds good. So first of all, let's kind of separate the notion of fragmentation from the Windows file system point of view and the storage. Okay, they're completely two separate aspects. We're focused on at the point of origination within the Windows file system and helping Windows prevent or avoid creating any fragmented files. Okay, and this relies specifically on our knowledge in your environment of where are the larger chunks of free space. And by telling Windows, instead of allocating this tiny little first segment of free space, we can match the size of the free space with the file request. Okay? Now, naturally, over the course of time, you may find that none of your free space is in any reasonably good large sections. So there is technology in our product to help consolidate the free space within the Windows file system. The second point I wanted to bring out here is that none of this has anything to do with memory. Write IOs are not allocated or cached. We're not holding on to all the bits and pieces of file allocations, kind of stringing or concatenating them together. We're just simply providing the intelligence so Windows, when the Windows file system is processing the I/O, it never breaks it apart in the first place. It has firsthand knowledge of where it's going to allocate space within the file system to initiate that write. And so therefore, we're always aware of kind of what's going on in the back end of things in terms of how large is the free space, where are those free space sections, do things such that we can move data around to consolidate the free space if it does become necessary, or even in some of the cases where you may already have some highly fragmented files that already exist. First of all, we don't need to touch every single file. Okay? A highly fragmented file that exists in your environment that nobody is accessing is not causing you a performance problem. So therefore, we just leave it alone. But if that file is important to you and you're accessing it, then we can do something about that file or prevent any newly created files or modified files from becoming fragmented. So I hope that kind of gives a little clearer picture there.
Yeah, sorry, Howard. I thought you were done. I didn't mean to talk over you. Sorry about that. No, that is fantastic. A couple more questions here real quick and we'll wrap it up. We are going to get down to the last 3 questions right now, so if you do have more questions, drop them into the box. Chris says, oh, my screen just shifted. Chris says, is a license good for only one VM server? The free license that you are getting from the webinar is good for only one server. It can be a physical server or it can be a virtual server. Now, this is the beauty of taking us up on the trialware offer as well, is that you don't have to use that to try the software. You can use our trialware to try the software and save that free license in your back pocket. So when you decide, if you decide not to buy anything from us, then you want to keep the software active on one VM or one physical server, then apply your free license to that server and activate the trialware. So that's a great way to go, but put it on everything. See where you get the most benefit, use that one free license that way. which perf counters? Typically split I/O and disk queue length are two good ones. Also read-write latency are good counters. And again, you want to point that directly at the VM. You want to be measuring the VM, not the host, because that's where the optimization takes place. And I also I've seen many times where someone captures their perf counters, they don't save it off into a different place and rename the file, and when they go for the afters, they overwrite the original perf counter logs, and they don't have their before-after captured. The other thing, too, is that we also want to look at your read-write traffic and when you installed Velocity, did you cap memory on SQL? Is Velocity tuned properly? So there's a lot of things to consider, and that's why we're standing by to help you with those evaluations to make sure that we check all the boxes, that you get the most complete evaluation possible in one shot and not lose that opportunity or have to redo stuff. Terry, thank you for your comment. He said, maybe he or she says that the last response answers the question, and it appears that I/O requests are defragmented at the OS level, so the I/O requests come through hypervisor more sequentially. Now, I don't want to get into semantics too much here, but there's a really important point in Terry's statement here of defragmented at the OS level. I want to focus on this word, the use of the word defragmented. That was in our Diskkeeper days. We actually were defragmenting, and that defragmenting, and I believe this point may have come across clearly, and again, I don't want to over focus on this, but this is super, super, super important. It's actually the reason, honestly, the reason we changed the name of the company. I've been here for over 10 years now. Howard's been here for 30 years. And when we came out with this new technology that replaced defragmentation, we talked until we were blue in our faces that it's not defrag anymore. It's prevention, it's prevention, it's prevention, to the point where we literally had to change the name of the company and rebrand because we had done such a phenomenal job being known as the #1 disk defragmentation software in the industry for the last 20-plus years. We actually wrote the disk defragmentation software native to the Windows operating system, and a lot of people don't know that. They also don't know that we've had access to the Microsoft operating system source code. We wrote the move file. I say we as if I had anything to do with it, but our company wrote the move file API hooks that are still native to the Windows operating system today. This is an incredibly deeply entrenched body of knowledge that our company and our engineers who have been here for 30-plus years possess. Now, with all of that knowledge, and I'm just going to kind of reemphasize this one last time here, we went ahead and our engineers went ahead and said, look, guys, we've got SSDs coming into the marketplace, and everyone is saying don't defragment SSDs because you're going to flash the cells and risk reducing the life of the SSD drive. Don't defragment. And what they were concerned about was excessive writes, because when you defragment in the traditional sense, you're rewriting the file. So what happened is we went, well, SSDs are coming on. They're too expensive right now, but 5 years from now they're going to be everywhere, and we've got people saying don't defragment. That was our bread and butter. What I realized when they came out with this new technology is that defragmentation has never been our product, ever. Our product has always been a sequential organization of data that could be read back quickly. Defragmentation was a means to an end. Our engineers went to the whiteboard when SSDs came out and they said, how do we get the sequential logical organization of data without having to defrag? And they cracked the nut. That's the IntelliWrite technology we were talking about. That's where we go in. Ahead of the write ever even being issued, we feed the file size intelligence into the Windows operating system, and we get that Windows operating system to write the file correctly the first time. There's no fragments to D. I mean, we prevent 90 to 95% of fragmentation. There's going to be 5 to 10% that gets through the filter, but that's fine. We don't care about that. We got enough to get the performance and get the prize done. So I just want to emphasize how unique this is. There is literally nobody else who can do this. We're sitting at a filter driver level ahead of when the write even gets issued. Sorry, I got on my soapbox there. I get passionate about this stuff, but I wanted to just really kind of emphasize that. So we are, let me see if anybody else has dropped another question in. I think we're good. I don't see any more questions. I see a bunch of people have dropped in the phrase both. I want to thank everybody for sticking it out this long. We have, I think, 95% of the folks who originally joined the call stayed on the whole hour. We really, really enjoyed this. Howard, and I also want to thank you for your expertise and for sharing your knowledge with us on the call today as well.
Absolutely, Jennifer. My pleasure. Thank you, everybody, for attending the webinar. And I look forward to working with each and every one of you.
All right, guys, that's a wrap. We will make sure that we have the webinar recordings out to you. If you do have another couple questions or anything like that, we will definitely get to you after the webinar. Make sure you drop in both or IOET or VMC as you exit, and thank you again for attending.